Hello, today I'll be explaining what is this intriguing number called e. While reading logarithms, you would have obviously heard of this thing. Now, e is the Euler's constant. Now, there are two types of logarithms. One is called the common log, which is log to the base 10, and log to the base e, which is the natural log. Now this is also called ln. So now if you have log 2 to the base e, then it can also be ln, it can also be told ln2 or natural log of 2. So today I'll be explaining what exactly is this e. So let us first understand the concept of growth. Now imagine you have a timeline. So 1, 2, 3, 4. These indicate the number of days. So on the you start off with say $1. Now this doubles every day. So you have $1. At the end of the first day, you would have $2. At the end of the second day, you would have 2 into 2, that is $4. Third day, you have 4 into 2, that is $8. Fourth day, you have 8 into 2, that is $16. Now, you can see a certain pattern of growth here. Now, this can be represented as the power of 2. So, here you have 2 to the power 0, 2 to the power 1, 2 square, 2 cube, 2 to the power 4, and so on. So you can see that there is a growth which is double the initial value. This can be also written as a 100% growth rate. Now, on the first day you have $1. So a 100% growth rate in 1 means 1 plus 100% of 1, that is 1 plus 1 is equal to 2. Now again over here you have 2. So you have 2 plus 100% of 2, that is 2 plus 2, 4. And then you have 4 plus 4, 8, and 8 plus 8, 16, and so on. So concentrate on the 100% growth rate over here. Now you can see that there is a discontinuous growth here. We have seen the growth only at the end of the time interval. That is, we have seen it at the end of the first day, end of the second day, end of the third day, and end of the fourth day. But we are not concentrating on what is going on in the between. But this is not how nature works. For example, your height today is 4 feet. After 1 year, your height will be 5 feet. A growth in 1 feet. But this is not a sudden growth in 1 year, right? This is a gradual growth, maybe millimeters over a period of time. So this is how nature works, with a continuous growth and not a sudden growth. So if you have understood the concept of growth, let us move on. Now let us assume that we have $1 at the start of the first year. Now every time we will be taking 100% growth. Starting off with our annual increment. Now on the first day we have $1. After 1 year, 100% growth, and we will have $2. Now moving on to a semi-annual growth. In a semi-annual growth, we will be dividing 1 year into 2 time periods. That is 6 months, and then another time period of 6 months. Starting off, let there be a 100% growth rate in all. So there will be a 50% growth rate in each and every time period. So we start off with $1. At the end of 6 months, we have our $1 plus a 50% of $1, that is $0.5. Now at the end of the year, we have our 1 plus 0.5, that is $1.5, plus a 50% on $1, that is $0.5, plus a 50% on a $0.5, that is $0.25. So we have a total of $2.25 at the end of the year with a semi-annual growth rate. Now moving on to a quarterly growth rate. Over here we divide a year into 4 equal parts. So you have 3 months, 6 months, and 9 months. Okay, so concentrate. We start off with $1. Now the growth rate is going to be $1 plus a 25% growth rate every time period. So it's going to be $1 plus a 25% on $1, that's 0.25. And then moving on to 1 plus 0.25, 1.25 plus 25% of this and a 25% of this. So 1.25 plus 0.25 plus a 25% of this would be 0.0625. Moving on, it will be this plus this plus this, total amount 1.5625 plus a 25% on this, 25% on this, 25% on this, and then it's gonna continue so forth. At the end, we would have a total of $2.441. So you can see that $2.25 is greater than 2 and $2.441 is greater than 2.25. So on increasing the number of time periods, we can see that there's an increase in the total amount at the end of the complete time period. So this formula is given by 1 plus 1 by n to the power n, that is compounding. So as n increases, the total value of this also increases. So now what does this have to do with E? Let us see. Now let us make a table of n and 1 plus n whole to the power n. Okay. So n, we take it as 1, 2. So at the end of, considering the concept of dollar and year, so we have $1 at the end of 1 year with an annual growth rate, it will become $2. Now we have $1 with a semi-annual growth rate. N refers to the number of time periods. So with a semi-annual growth rate, it will become 2.25. Now if we divide a year into 4 parts, it will become 2.441. And then 12, 2.613. So now your mind must be thinking something crazy. What if I make this infinite? Then I will have really great amount of money with me at the end of 1 year. So let's see what happens. Now let us make it 365. So we have divided a year into 365 time periods, and the final amount is 2.7146. So this is obviously greater than 2. Now your mind must be thinking, why don't I keep increasing it? Let's see. So I make this 1000 time periods, it's 2.7169. Now do observe, 10 to the power 4 time periods, it becomes 2.7184. 10 to the power 5 time periods, 2.718268. 10 to the power 6 time periods, 2.718280, and so on. Now you can observe that 2.718 is common here. Now this is what is E. This is the value of E. So now we can say that E is the maximum amount. E is the maximum amount that we get after continuous compounding with 100% growth rate after one time period. So one time period refers to the entire cycle over here. So E refers to the maximum amount, that is 2.718 after continuous compounding, like so many times you've compounded it with 100% growth rate, total growth rate after one time period. So the 100% growth rate refers to the total time period, right? So the growth rate in every sub time period will change. That will be 100 by n depending on the number of time periods. So this is what is E. Now your question might be, what if we change the growth rate and the time period? Will the value of E change? Yes. It will be E to the power RT. Now imagine you have a 200% growth rate for 5 years, then it will become E square, because it's when it's 100%, we take e to the power 1. So when it's 200%, we take e to the power 2, because 100 into 2 is 200. Okay, so it doubles every time. So e squared. So uh, uh, e squared, and r over here is 5 years, as the time period is for 5 years. So this process happens for 5 years. So 2 into 5. So e to the power 10 would be our value after continuous compounding at a 200% growth rate for 5 years. So I hope you've understood what is e,